Welcome back, class. Thanks for tuning in. We are in week 9, part 1. It's kind of crazy. This is the last week before summer break for you. We're going to be jumping right into the iPad and talking about our topic today. So, here you go. So, what you're seeing in front of you is our topic today. We're doing circles. This is the last topic that I want to cover. It's based on arc length, the actual distance on a curve, a circular curve, the area of a circle, and the circumference. Now, circumference and arc length are kind of based on each other. I know this is going to seem really weird. This is going to be some wild stuff that you can see with this. It's based on central measure, so the stuff we did last week. So it's kind of all fitting together in kind of a weird way. But this is our last stuff before summer break, so let's jump right in. Now, again, I know some of you are actively participating each week, and I always appreciate that. If you've been working on any late assignments, redo assignments, trying to get your grades up, remember that stuff is due this coming Wednesday. So I think I've sent out reminders on that. So just kind of keep that in mind. Try to get them in early so I can get them graded. But let's jump right into the video, and hopefully this will make sense to you. I don't have a lot of slides here. I only got 2 slides to kind of talk about topics, so they're just generic slides, and I'll just do a bunch of problems on them. So let's jump right in. So what you're looking at here in front of you, this is the idea. So if you want to find the arc length, that's this little L here. This little path, this circular path you're taking on a circle, this arc, that's what they call it, the arc length. There's a formula for it. And all you need is the angle that's in the center, the central angle of your circle. That's what we talked about last week, the angle at the center. And you need the radius of your circle. The radial distance. It doesn't matter where the radius is. The radius could be anywhere. It could be right here. Maybe they give you that distance. And when you have both of those, you can find arc length. Now, you can kind of see the generic formula. Now, your textbook has, I think, this one. My pre-calc and calc textbooks, they have a formula that is based on this. This is the way it looks. I know this seems really weird. The S stands for arc length. So S is arc length. The R is radius of your circle. That is the distance from the center to the outside, the actual stick length. And then the theta, that's a Greek letter. It's a circle with a little line in the middle. It's called theta. It is a Greek letter. It stands for an angle. Now, it's not just an angle. It's not like 30 degrees or 40 degrees. It's got to be in what they call radian measure. So it's got to be a different label. It can't be just degrees. Now, just let me give you the idea here why it can't just be like degrees. So let's say the angle I was going at right here, let's say this was 2 inches for my radius of for my circle, and let's say the angle right here is 120 degrees. That kind of looks like a 120 degree angle right there. You don't just take 2 times 120 and get the length on this circular path. It won't make any sense. If you took 2 times 120, you're telling me that my arc length, the actual raw distance that you're seeing right there in front of you, that would be 240 inches. That doesn't look like 240 inches. That looks like about 3 or 4 inches, maybe, if that first line was 2. So how do they get it? There's a way to take the angle that you see there, that 120, and convert it. So what you do is you do this. You take the radius. So I'm still using the same formula. So the radius in my case is 2 inches. And then I'm going to take it times my angle. Now this angle, I'm going to put this in parentheses. Whatever your angle is, so mine is 120 degrees. You're going to take it times pi. The pi number, sorry, I'm getting a bunch of messages. So you take it times pi, 3.14, and then you divide by 180. That's the simple conversion, and it will change any degree angle into radians. And that will convert it to what we need, and it'll actually give me a real number. So I'm going to actually type this in so you can actually see the real number here. Let me jump right to my calculator here. This makes sense. So you're seeing the calculator in front of you. Let's do a couple of calculations. So I'm going to take 2 times the 120 times pi 3.14. Now I think I have a pi button, but I'm just going to type in 3.14. And then divide by 180. And boom. What it's telling me is 4.186 inches. Now again, this is a decimal approximation. It's not super exact because the idea here is that I totally rounded off pi, 3.14. There's an infinite number of decimal places, so this is close. Maybe it's 4.2 inches, let's say. It'll be close enough. But that's the idea, and that's what you're seeing there. That 4.18. That's the arc that I have drawn there in red. So kind of interesting that you can use a simple formula. Now I said earlier, like this formula is based on circumference. So if you went all the way around a circle, you take 360 degrees, right? Full circle. You can figure out that by taking 2 times pi times r, because 2 times pi times r, that's this formula you're looking at in front of you. It's the arc length formula. The angle just happens to be 360. So that's the idea. So now if I wanted to find circumference, like I'm saying, circumference formula is 2 times pi times r. Hopefully you can see that. Maybe I'll go just to my iPad here. There we go. So my radius would be 2 inches. You can plug this in. So the exact answer is 4 pi inches. And 4 times 3.14, what is that, about 12-ish? Let me go to calculator here. 4 times pi, 4 times pi. I actually have a pi button here. Okay, yeah, 12.5. So 12.5 inches if I rounded it. So that's the full distance all the way around. I'm just doing a select part of it with the problem I made up here, right? So, but the full circle all the way around is 12 inches, but just the little chunk that I did there was 4. So I did about 1/3 of the circle, which actually makes sense. Now, area of the circle, if you had to do area, it's pi times r squared. So 2 inches, I have to square that. That means take it times itself, and then take it times pi. So that's 4 times pi. And so my area would actually be the same, 12.56 square inches squared, or square inches. So that's how many little squares would perfectly fit in there if you went 1 inch by 1 inch. All right, it just happened to be the same number. Don't read into that. I just made up a problem that actually worked out to be perfect numbers. Sorry, I probably shouldn't have used 2. I should have used a weird random number, so it didn't work out nice and pretty. Because again, if you squared like 3, it wouldn't work out to be the same number in this case. Let's jump right into our our last slide here. So what we've been looking at here, let me go right back to the video feed of me. This is something, this slide that you're looking at here in front of you is a slide that we used last week. So if you had your central angle was 63 degrees. Well, if I told you your radius was, let's say 5 inches here, then the idea is that I can figure out this arc, the actual length of it. Not just, what the angle is at that arc, the measure of arc B to A or A to B, that arc, that's 63 degrees. That's the angle at the center. That was something we talked about last week. That's a minor arc. It's smaller than, 180. I'm talking about the actual length of the arc from B to A, the actual raw distance. So that's the formula we just went over. This one. So that's the arc length. So my radius is 5 inches. I take that times my angle, but I have to convert it. So 63 degrees times pi. Oh, come on, just let me write there. Times pi, divide by 180. Sorry, I can't write in that weird dead space there. This is just a dead space. And this will tell me exactly the length of this arc, if that was to scale. I'm going to guess it's around 5 inches. This length right here looks almost identical to that length in terms of if I just kind of eyeball it. So I'm betting it's going to be around 5 inches because they about look the same. That's curved, so it could be a little deceiving. So let's do the math here. Let me go right to my calculator. Let's clear it out. All right, so what do we have? We have 5 times 63 times pi. I'm going to use the pi button this time. And then divide by 180. Yeah, I'm getting 5.49 inches. So it's about 5.5 inches. And that's the arc that you're seeing there. Yeah, kind of eyeballing it, kind of looked about the same. It wasn't like the last one where I went way further. If you need to figure out the full circumference, again, circumference formula is 2 times pi times r. So 2 times pi times the radius, which in my case is 5 inches. And then the area of that circle is pi times r squared. And again, these will not end up being the same number like the last time. I picked 5 inches, not some weird random 2. That just happened to be some lucky number I just picked last time. So, all right. hopefully this makes sense. This is what our activities are based on this week, so you can kind of go through and kind of see how they're working. But again, thank you for everything that you guys have been doing. I really appreciate it. It's one of those things that I know it's kind of tough when you start doing this stuff on your own, and you're trying to get through some of these problems. But again, thank you for all the work you guys have been putting in, and I hope that you're safe and healthy and that you're taking care of each other. But again, check your emails. I know the school's got a lot of stuff coming up here soon, student council stuff and end of the year check-ins. So check your emails, get your homework done for other classes and mine if you have anything, and hope to see you real soon. Bye.